Hi, everybody. Welcome back to Dave's Math Channel. This is my continuing feature on the Math Lovers book, three-volume series I wrote from 2019 to 2022. Anyway, I'm in section 8.4 of chapter 8, which is on computation, and I'm talking about loops, different kinds of structures, and computer programming. And one of those structures is loops. And I'm going to have several videos on loops because there's a lot of different kinds of loops. But the first kind of loop I'm going to talk about is a if loop, and there's variations on that. There's if, and there's also if slash else, and there's also if slash else if slash else. And they're all pretty similar, but I'm going to go over each one and give some examples. So anyway, let's begin. So, first I have to tell you what a loop is. A loop is something that can get repeated. It either gets repeated or it gets executed conditionally. In the case of if is something that gets executed conditionally. If some condition holds, then it runs some code. And there's different types, like I said, if. I'll just go into some. Anyway, if is a type of loop. There's other types of loops too, like for loops and while loops, and I'll get into those later lessons. But today we're talking about if. So the simplest type of if loop is just a simple if loop, and this is how it looks. So we write this within our code. We say if some condition holds. Condition can be anything, like if, for instance, x is less than 5 or x is one of your variables, then do something. So it'll do that code. It'll run this code only if the condition's met. So for instance, if x was 3, it would run the code. If x was 10, it would. So that's how an if works. And something closely related to if loop is an if else loop. So you might want to, do something if the condition is met, but then do something else if it's not. So for instance, if your code was something like if x is less than 3, do one thing, and otherwise do the other thing. If x was 2, then it would do the first thing. If x was 5, it would do the second thing. So that's kind of how an if else loop works. And a lot of times this is represented by a flow chart. And usually the way if conditions are represented in flow charts is you have a little diamond shape. These are called nodes. These kind of regions in this diagram. This is what a flow chart looks like. You always start at the beginning of the program. Usually they have them going from top to bottom. So your starting point in your program would be the oval shaped start node on top, and then you can see these arrows. So you start your program, and then your arrow just means you go to the next node. And if the next node was an if condition, then if the if condition is true, then you go to the left, and if it's false, you go to the right. So that's kind of the general structure of an if else loop. The if part goes for the left, and the else part is for the right. And then you get out of the loop. You always have to say like end if, or you have to end your braces so it knows that you're done with your loop. And once you're outside the loop, then you run some other code and you exit the program. So that's how an if else loop looks in kind of the representation, but it's a diagram. Anyway, so I think I better give you an example. Suppose we want to write code that determines whether a given input is even. So we're inputting an integer, an int type, and I think you guys know that every integer is either even or odd. And specifically, it's even if it's divisible by 2, and it's odd if it's not. So if we had code where you're given some integer x, and you want to determine whether x is even or odd, what do? You test whether it's divisible by 2. And the way you do that in C is you use this mod function, this percent means mod, that's the remainder upon division by 2. So we test whether x percent 2 is equal to 0. That just means whether the remainder after you divide x by 2 is 0. And if it is, then we say that the number is even, and otherwise we say that it's odd. So that's how you would do that. This is how you do that with an if-else loop. Anyway, so that's a pretty simple example. Um, and then you can have more complicated structures. In general, you can run as many conditions as you want. And if else just has two conditions. If the thing in the diamond's true, do one thing, otherwise do another thing. But you can nest them. You can say, well, if some condition holds, do one thing, and then you can check whether some other conditions hold, and if that conditions hold, do something else. And then if not, else, eventually you have to go to just else. So this is if else. This has three conditions. So you would have condition one if the first condition is true. If not, then either you go to code two if the second condition is true, but if the second condition is false, you go to code three, which I just wrote as code here. But and then here's another flow chart that kind of shows you what's going on. Actually, this one has four conditions, I guess. So there's three diamonds. Notice that we're checking three different things whether they're true or not. So the first if statement you run into, if that one's true, go down. That's the true condition. If it's not, go to the right, and then we go to another if condition. And if that condition is true, we run the second piece of code going down. If not, we go to the right again. And then we meet with a third if condition. And if that condition holds, we go down. And if not, remember I said there were four cases here. So if all three of these conditions were false, you'll be going to the right. And you'll run the fourth piece of code. And then you get out. But there's nothing magic about four. You can have as many of these as you want. And there's actually, in C, there's another type of structure that does this. It's called switch. I don't use switch very often, but switch is basically the same thing as if. It's just you don't have to keep making ifs galore. You just say switch, case one, do something, case two, do something, case three, do something. Same structure, basically, but a lot of people prefer switch. I think it's sort of a personal preference whether you use like if or switch. I usually use um, if else, this kind of thing. But anyway, so now I think I better give you another example. This is a more complicated example. This one, I'm asking to compare two integers, x and y, to see which one is bigger. And there's three possibilities: either x is less than y, x is greater than y, or x is equal to y. So we want to check each of those conditions. So and we want to say what the relationship is between x and y. So how do we do that? Well, I mean, you can write code that does almost exactly what I just said. So your first condition, if x is less than y, then you say x is less than y. Of course, it'll print out the numbers x and y the way I've written it. So for instance, x was 35 and y was 50. It would say 35 is less than 50. But then suppose that wasn't true. Suppose y was 20. So it's going to first test whether 35 is less than 20, and it's not. So it won't run the first piece of code, but then it'll go to the second piece. Is x greater than y? Is 35 greater than 20? Yes, it is. So it'll output 35 is greater than 20. And they could be equal. So maybe they're both 35. Suppose x and y were both 35. Well, then it's going to first test whether x is less than y. 35 is less than 35. That's not true. So it skips that statement, and then it checks whether 35x is greater than y. Then again, they're both 35, so 35 is not greater than y, so it doesn't run the second piece of code either. But then the else, there's only one other possibility, that they're equal in this case. So then I'll say 35 is equal to 35. The two given numbers are equal. So that's how this code works. Anyway, so that's just kind of a simple example where if else will do the job for you. Anyway, that completes my video for today on if loops and their variations. So thank you for watching. Long live math, and I'll see you guys next time. Bye.